Hi, welcome to the channel. Here I post challenging math problem daily. If you like this video, then give it a thumbs up and subscribe to the channel. So without further delay, let's start. Today, the problem is consider two circles. These two circles with the radii A and B are given with the center A comma 0 and 0 comma B. So there is a mistake. Actually, this is B comma 0. Okay. So this center is B comma 0 with the radii B is greater than A, and another circle with the center C is moving inside this crescent such that these two circles touches with each other. Okay, now we have to find the locus of this center of the circle C. So how can we proceed? So if you see this picture intuitively, you can say that this locus must be a ellipse. Okay, so if we check for this, so let this locus is x comma y. Okay, this center is a comma 0 and this is b comma 0. Okay, now what we can do here is, if we generalize the standard form of ellipse at which the variable point p, let's say x and y, and there are two fixed points which are known as the foci of the ellipse, such that the sum of the distance ps1 plus ps2 is a constant. Okay, and the constant is the 2a. Okay, the semi major axis. So if we check here, this C point is the variable point, and this A and B, the centers are the foci of this ellipse. So if we check and find, if we find this uh, relation is satisfied, then we can establish then this is an ellipse. Okay, then we will go for the equation. Okay, now let's see. Now this circle is moving. Okay, so at some point, at some time, this will come to this point. Okay, so this is the C. Okay, so let's assume this radii of this small circle is A, radii of the large circle is B, and radii of the third circle is just a minute, radii of the third circle is C. Okay, or R, we can say R. Okay, now this R is varies. Okay, now if we can check as this is P point, say this is S1 point and this is S2 point. So P, wait, PS1 means the distance between the smaller circle and the variable circle. So this radii is A and this radii is R. So A plus R. Similarly, PS2 means the distance between the larger circle and the variable circle. So this distance is B minus R. Okay. Now, if we add this two equation, PS1 plus PS2, we get this R will get cancelled. So we have A plus B. Now this A plus B is always a constant. These are the two fixed circle. So we have established the relation. Okay, this center point is center point will form then ellipse. So what we can write here is, now simply this is the length of the semi major axis of the ellipse. So we can use another form, okay, another form. So we will write this x minus alpha square over m square plus, because a and b are taken, okay, so we are writing this general form of ellipse. So we have to find all the values alpha, beta, m and n. Now this m is the semi major axis and n is the semi minor axis. So according to this, 2m equal to a plus b. So we get m equal to a plus b by 2. Okay. Now this alpha and beta are the center of the ellipse. Okay. So this alpha point and beta points are the midpoint of this two foci point. So now what we have here is, I am just writing, this is S1. So this is a comma 0. This is S2, which is b comma 0. Okay. So this is the vertex. Let us, this is a. So it is the midpoint between two foci. So vertex a equal to alpha comma beta. So we can write alpha as a plus b by 2 and beta is 0. Okay. Using midpoint formula. Now we have find out the value of alpha, beta and m. Now only n is left. So to find the value of n, what we can do is, we know this S1 and S2 are the foci points. So we know the foci of an ellipse is nothing but alpha plus minus me. Okay. Where E is the eccentricity of the ellipse. So for S1 point, alpha minus me. Okay. So S1 is A. So we can write this A equal to alpha. Alpha is A plus B by 2 minus this M is A plus B by 2 into E. Okay. Now we will find the value of E from here. So what we can do is take E that side, we can write as A plus B by 2 comma E equal to A plus B by 2 minus A. Okay. So we just simply write this, it will cancel. So B minus A by 2. So 2 and 2 get cancelled. So E equal to B minus A by B plus A. So this is the value of E. Okay. Now we know the value of E. So we also know that eccentricity of an ellipse equal to under root 1 minus n square by m square. Okay. So b minus a by b plus a. Okay. Make this square, squaring both sides. So we have n square by m square. So m square, we can write this m as a plus b by 2 whole square, a plus b by 2 whole square. So 4 is there, and this is b minus a by b plus a whole square. Okay. Now simply solve for n. So 4n square divided by a plus b whole square, 1 minus b minus a whole square divided by b plus a whole square. Okay. So this b plus a whole square will get cancel both the side, and we have this 4n square. Now b plus a whole square minus b minus a whole square means 4ab. Okay. So this is 4ab. So 4ab, and this will get cancelled. So 4 n square, 4 also get cancelled. So we have n square equal to ab. Okay. So our final we have all find the all values of m, n, alpha, beta. So we can write the ellipse as x minus a plus b by 2 whole square divided by, this is x minus alpha. Okay, alpha is not square, this whole thing is a square. Okay, so this is square, just a minute. This is x minus alpha whole square divided by m square. M square is a plus b by 2 whole square. So a plus b by 2 whole square plus y, beta is 0. So we just neglect, and this is a b n square, and this is n. So the final equation of the ellipse is this. Okay. So this is all for today. See you tomorrow.